Hey guys, in two, when we're talking about equations with one variable. So the first part's just going to be, combining like terms. We've got this first one, we've got 4x plus 8x. I can combine that 4 and that 8 because they are like terms, meaning they have the same variable, right? So 4 plus 8 is 12. Okay, and then now I have multiplication happening here. Whenever you have a number next to a variable, that means multiplication. So you got to do the inverse or opposite of 12. So you divide by 12 and get x equals 3. You can also think about it as what number times 12, what number is that x, what number times 12 gets you to 36, if that kind of helps you, think about that in a different way. Okay, so now we've got some decimals right here. I'm going to do the same thing, except instead of adding over here, I'm going to subtract, okay? If there's a question about why I added here and not did the opposite, or the inverse, it's because they're on the same side of the equal sign. They're both on the left side, and so you don't do inverses when you're doing that. The only reason I did the inverse right here is because I'm like basically taking this 12 across the line of the equation. So when you do that, you have to do the opposite to cancel it on the left and balance the equation on the right. So okay, so I'm just going to use my calculator for this. I'm going to say 5.79 minus 2.43 gets us to, hold on. Where was I? 5.79. There we go. Minus 2.43 gets us to 3.36. 10.08. And then I take that 3.36 and I divide it on both sides. So 10.08 divided by 3.36 gets you to 3. Look at that. 3 on both of them. So special. Anyway, Kendrell used a third of his allowance on V-Bucks and half of his allowance on Robux. If he spent $30 on virtual currency for these games, how much was his allowance? So we're going to say X equals allowance, and that's how much money he got. Okay, so I'm going to take this 1/3, and I'm going to multiply it by his allowance, right? Of means multiply, so 1/3 times X, and means plus, okay, 1/2 of his allowance. So I add those together, and then $30 was how much he spent on virtual currency. So basically you add this number to that number and you get that 30, okay? So now we're going to multiply fraction bus basically. So I'm going to take 3 times 2 and multiply it together to get to 6. That'll get rid of the fractions. Okay, you could also multiply by 3 to get rid of this and make this into a different fraction and that, and then also multiply by 2. That would do the same thing. Okay. All right, so now I'm just going to multiply by 6 for these. 6 times 1/3, or 1/3 of 6 is 2x, and then 6 times 1/2, or 6 divided by 2 is 3x. 6 times 30 is 180. I add these two together. 2 plus 3 is 5. And so then I'm just going to divide by 5. And then 180 divided by 5 gets you to 36. $36 was his allowance. That's a bit of an awkward phrase, or a bit of awkward phrasing for that. But what are you going to do? All right, so $36. Okay, so now we've got variables on both sides. So now we kind of have to do, we basically have to get the variables together. So I've got this 2x and this 10x. And so I like to bring my variables to the left side and my numbers to the right side. It is not required that you bring them to the left and to the right like that. I just like my variables on the left side. Most math teachers do, I would imagine. So those cancel. So I'm now left with 20 plus 8x equals negative 36. So since this is minus 36, you got to carry that down. Okay. So now this is a positive 20. So the opposite of being positive is subtraction. So I'm left with 8x equals negative 36 minus 20. Now if you're going to put this in your calculator, oh look, 36, I'm just going to make it negative. Okay, you make that negative after, and then minus 20 will bring us to negative 56, right? Negative 56. Divide by 8. Okay, take this, divide by 8, gets you to negative 7. All right, so now we've only got one fraction, right? So instead of like combining them together like this to figure out a different number to multiply by, I can just multiply by 3. So I'm going to multiply everything by 3. Okay, 4 times 3 is 12x. 3 times negative 6 is 18. Now for this, right, this 3 and this 3 cancel out and leaves me with 2x. and then plus 12. Okay, so I'm going to take that 2x over. It's positive, so I can subtract it. Gets me to 10x minus 18 equals 12. I'm going to add, oh, nah, I gave it away right there. Add those together to get to 10x equals 30, 12 plus 18. We divide by 10, and again we get to x equals 3. Look at that. So many x equals 3. Okay. Aaron and Jasmine both work at a furniture store selling furniture. If Aaron has a base salary of $750 per week and makes 6% on her sales, Jasmine has a base salary of $1,100 per week and makes 2% on her sales. What amount of sales will give them the same salary? Question mark. So X is going to be amount of sales. Okay. And so then when we convert, these percentages, right, we just multiply by, basically just move the decimal over twice. So it's going to be 0.06. So we'll say 0.06x plus 750. And we want to see when it's going to be the same. So I'm going to get this 0.02x. It's a little kilted off there, my bad. Plus 1,100. And then we just kind of do the same thing. I know it's decimals, but we've got calculators, right? So I subtract that 0.02x over. The reason I like to bring it to the left in this case is because this number is bigger than this number. So basically that's kind of what dictates whether I go to the left or the right. I bring the smaller number to the side of the bigger number. This is going to give me 0.04 plus 750 equals 1,100. I subtract 750 on both sides. And just because I don't want to think because it's early in the morning, 1,100 minus 750 is 350. So I'm at 0.04x equals 350. And I divide by that. And I'm going to get whatever that is. 350 times 0.04. Nope. Divided by, my bad. Divided by 0.04 gets us to 8,750. So if they each sell 8,750 in sales, their commission, their base salary will work out kind of on the left and the right to equal the same number. Okay, that's kind of the idea here. Okay. So I've got some distribution happening here. What we're going to do is we're going to take that 8 and we're going to multiply it, distribute here to get rid of the parentheses, right? So 8 times 3 is 24. 8 times 8 is 64. Okay. Now I've got this 7x. It's minus, so I'm going to add it on both sides. Okay, 24 plus 1 is 31. X plus 64 equals 33. Now this is going to give us a negative right here, right? Because 33 is smaller than 64. So I'm left with 31x equals, let's do this, 33 minus 64. Oh, look at that, negative 31. So now we divide by 31. And we get to x is negative 1. Okay. Now we're going to do the same thing. I'm going to show the distribution on the bottom actually, because I should actually shift that down a bit. Negative 4 times x is negative 4x. Negative 4 times negative 1 is a positive 4. And negative times a negative gives you a positive. Okay, negative 5x plus 1. Now, since this negative 5 is smaller than that negative 4, I'm going to add it. So that actually works out to just x. You can use your number line for that or use your calculator, right? If you're using your calculator, this is how you do it. You would say 4, make it negative, and then you add 5, boom, to get to positive 1. Okay. Now I'm going to subtract 4, and I get to negative 3. Again, since your 1 is smaller than the 4, your answer is going to be negative. Like so. Okay, again, you can use your calculator for that. Right? 1 minus 4 gets you to negative 3. Okay, now, so I've got 2/3 and 1/2. This is actually similar to this problem because it's basically, the denominator is the same here. So I know I'm going to multiply by 6 to get rid of these fractions. Now, when you have these parentheses like this, you actually only have to multiply the fractions by 6 because then after you do this, you're actually going to multiply to get rid of you're going to distribute to get rid of the fractions. So basically it's kind of all happening at the same time. So 6 divided by 3 is 2, times 2 is 4. Okay, or 6 times 2 is 12, divided by 3 is 4. Okay, 1/2 of 6 is 3. All right, so now let's use purple. unless it runs out of ink here, which it might. Yeah, it's running out of ink. That's disappointing. It's too blue. Okay, 4 times 2 is 8. 4 times 4 is 16. 3 times x is 3x. 3 times negative 3 is negative 9. Okay. Now this 8x is bigger than this 3, so I'm going to bring this 3x to the left side. This gets us to 5x plus 16 equals negative 9. I subtract 16 on both sides, and I'm just going to bring it over here because I got a lot of room. I'm going to say 9, make it negative, minus 16 gets you negative 25. We'll divide by 5, and our answer is negative 5. Okay. And these are all, special solutions, so it's going to be either, those solutions or infinite solutions. Here. So I'm going to distribute, again, to get rid of these fractions. Distribute to get rid of the parentheses. So 7 times 1 is 7 minus 42x equals negative 42x and plus 7, which is the same thing on both sides, right? You can rearrange this if you want to 7 minus 42x. And so whenever you have the same thing on both sides, that's going to give you infinite solutions. Basically, any number that you plug into this is going to solutions. Any number that you plug into this is going to give you the same on both sides. So really, it would be literally any number. That's why it's infinite solutions, because you could do 1, 2, 3, 4, a million, negative 752. Really, any number that you put in here is going to make this. You put a fraction and you put a decimal in. As long as it's the same number on both sides you put in, which it should be because they're both x, it'll give you the same on the left as it is on the right, which again is what we want with that equal sign. Okay, so now I'm going to distribute here and here, here and here. 4 times 3 is 12x, and 4 times 3 is 12. Give me a second here. Oh, thanks, Scott. Sorry, guys. Okay, all right. Negative times a negative is a positive. Negative times a negative is also a positive. Okay, so yeah, and then I combine these like terms. I get to 12x plus 12 equals 12x plus 12. Let's actually solve this a little bit more to kind of like emphasize this, right? Because we got the same thing on both sides, right? I've got 12 equals to 12. So same thing on both sides gives you infinite solutions again. Okay, so now we're going to do this one. So you can kind of probably guess what this one's going to be. By the way, this is a negative 1. Okay, 4 times 2 is 8. 4 times 8 is 32. Negative 1 times a negative 8 is positive 8x, and negative 1 times 7 is negative 7. So I've got the same variable here, which when I kind of bring those together, those cancel out. When it's not 0x, it's going to give you 0. We've got 32 equals negative 7, which is not true. So since it's not true, there is no solution to this. You'll never be able to find a number that will make this equation true. That will make this equation the same on the left as it is on the right. So there you go.